every single day. Make sure you're doing the homework. I've never ever, in all of my years of teaching, I've never had a student fail my class, whether it was geometry or any other class, who did their homework every day. They might not understand anything, but somehow I'll work it out. If you do your homework every day, you're not going to fail this class. So if I know that you're putting forth the effort, somehow you're going to pass. Problem 18, you said, Mackenzie? I'm not going to draw all the arrows and everything on here. That's line R, that's line S, that's line M, that's line N, and they tell us this angle is congruent to this angle. And they want to know, decide whether there's enough information to prove that line N is parallel, or line M is parallel to line N. If so, state the theorem. So if I'm looking at these two angles, which line do I want to use as my transversal? S. So I'm going to split off those three, and I'm sort of getting rid of line R there because I really don't care about it this time. I know that that angle is congruent to that angle. For those two angles, anything special to each other? Alternate exterior. Did we have a theorem that talked about alternate exterior?
Yes.
If alternate exterior angles are congruent, then do we know those two lines are parallel?
Yes.
And that's what we write. Yes. And a theorem, the reason would be if alternate exterior angles congruent. And as I'm writing this theorem out, these four theorems are basically the same thing over and over again, right? You're just changing a couple of words in it. So make sure you know all four of them. If alternate exterior angles are congruent, then what do we know? Parallel lines, or lines are parallel, whichever way you want to say it. That's your reason. Next question.
34. I know after last chapter we said we were never going to do any more two-column proofs again, right? Is that what we said? That's what you wanted to hear, right? That's not the way it's going to work, sorry. 34. I'm going to draw this picture up here. Then you guys can just help me with the given information and stuff. Is this M? Line M? Is that right? Line N? That's an N. Ignore that straight thing. Is that angle 1? Where's angle 2 at? Vertical to that? Where's 3? And what's the given information say? Angle 1 and angle 3 are supplementary, so I'm just going to write that up here. Angle 1 supplementary to angle 3, no real good way to show that in the picture. What's the next piece of given information say? That's all of it? If that's all the given information, then we got to come up with other information from where? The picture, your brain. Do we know anything else in there? 1 and 2 are congruent, so let's mark that. Angle 1 is congruent to angle 2. How do we know angle 1 and angle 2 were congruent? The vertical angles are congruent. So I'm going to write that down here somewhere, probably somewhere in our proof. We're going to use that, right? Just making myself some notes here. Anything else from this picture that we know? 2 and 3 are what? Supplementary. How come? They're the consecutive interior, right? So I'm just going to write something like that, just a little note to remind me. We know that they're supplementary. Well, do we know that they're supplementary? They would be supplementary if what was true? If these lines were parallel. So we might use something like that, but we can't actually say that, so we'll keep that in mind. They already told us 1 and 3 are supplementary. So maybe I'm wrong, Kenneth. Maybe you do know now that 2 and 3 are supplementary, because what could we use there? Substitution. That's probably what you were thinking, right? I thought you were thinking a different route. So probably we're going to use substitution. Well, if these two are supplementary, then what can we say about these two lines? Then they're parallel. That's what we're trying to prove. So we should be able to do this. What's our first column called? Second one? Tell me our first statement.
Angle 1, 2.
Angle 1 is supplementary to angle what? 3. How do we know that? Given. Now I heard somebody start to say something different than that. That'd be fine. There's other things you could have started with there. I usually like to start with the given, just so we know that we have that first one at least. Now, do you have to put all the given right here at the beginning? No. This time there's only one piece of given information. So now we know 1's supplementary to 3. That was all the given. What did we say? 1 is supplement. No. 1 is congruent to angle 2. How did we know that? Vertical angles are congruent. If you can't pick out vertical angles by now and know that they're congruent to each other, then see, I'm trying to be nice here. I don't even want to say anything because thank you. Thor said it for me. I didn't have to say it. You got it. That's one of the things. If you can't find vertical angles by now and know that they're congruent to each other, that's one of the major things that you have to be able to pick up on. All right? That and like linear pairs, supplementary angles. Now look at what we have in 1 and 2 here. If 1 is supplementary to 3 and 1 is congruent to 2, now what can we do? Substitution. You can take out 1 up here and stick what in its place? 2. Take it out and stick it right in its place right there. So what are we going to say? Angle 2 is supplementary to angle 3. Notice I'm using my symbols on everything. How do we know that angle 2? What did we just do to go? Substitution property. Substitution property. Are we finished? Once we know that those two are supplementary, what would that tell us about these two lines? They're parallel. So M is parallel to N. Anybody know our reason? And how are we going to write it? If consecutive interior angles supplementary, then parallel line. Notice over here in the reasons. Did I mention angle 1, angle 2, angle 3, line M, line N, any of that stuff over here? These are all like generic just reasons that could work for any 2-column proof. All right? Don't stick these numbers and stuff over here in your reasons. What's our next statement going to be? That's it. So let's look at this. How many points would this be worth on a test? 8 points. Should everybody get that point right there? I hope so. How about that one? What did we just say about this one, Thor? You gotta know that. So if you can't pick out that you have vertical angles right there, everybody should be able to get that. That one. Should everybody be able to get this one? Yeah, that was in the proof statement. So you know that's got to be in there somewhere, your last statement. So right now, how many points? 5 points out of 8. That's knowing, the only thing that you know about geometry is the fact that these are vertical angles and they have to be congruent. 5 out of 8. Anybody know what percentage 5 out of 8 is? Nobody's got a calculator laying right there so that Zach doesn't have to guess. He's just making up numbers, 70, throwing them out there.
62%? Is that better than a 0? Next question. This is 3x, that's 2x plus 20. They want you to find x so that these two lines are parallel to each other. Well, what kind of angles are those two? Alternate interior. Sorry, I started to say the wrong thing. Alternate interior angles. They form a 0 and n there. Well, for those two lines to be parallel, what has to be true about those alternate interior angles? So tell me the equation I can set up.
2x plus 20 is 3x.
Somebody started to say it the other way around. Does it matter? Makes no difference. Tell me how to solve it.
Subtract 2x on both sides.
Subtract 2x on both sides.
20 is x.
20 equals x. What'd they ask us to find? X equals 20. So if x equaled 20, what would this angle be if x equaled 20? 60 degrees. What would this angle up here be? 60 degrees. It got to be the same. What would this angle over here be? 60. What would this angle be? 120. How about this angle? 120. How about this angle? 120. How about this angle? This angle. Should be able to find all those, right? Yep.
I was wondering if this was correct. I also got x equals 20, but I did something different. I distributed 3x into 2, and I got 6x plus 60 equals 180. And then I did minus 60, got 120 divided by 6x, and I got x equals 20. Would that have worked?
Tell me your original equation again.
6x plus 60 equals 180. And then I minus 60 on each side. Then I divided by 6x, and I got 20.
I think you got lucky just because what's true about this angle, 60 degrees and the 120? It's half of it. So I think you got lucky just because that one ended up being half of it.
Yeah, because I got 120 divided by 6x, and I got 20.
So you have to set it up this way. This angle, that angle, alternate interior. So this should be
It's in the book, the 2x was 20 in parentheses.
right. But even though it's in parentheses, those two angles are alternate interior angles, so they're still equal to each other.
That's why I
Not
changed it.
not supplementary. So remember, Mackenzie brings up a good point here. When that 2x plus 20 is in the parentheses, is it in there because they're talking about distributing something? It's in there because they want you to know that it's a angle. So when we go to set up our equation, do we really need these parentheses in this case? No, we can just drop them. The only time you need the parentheses is if they give you some number outside of there like that. Then we need those parentheses. Otherwise, just drop them.
Sorry.
That's all right. Hopefully it straightens you out now and you understand it a little better. Oops, wrong way. This is your quiz. You're going to work it with a partner. When I get done explaining Tyler, it's 9:24 right now. I'm going to watch that clock very closely because you got 10 minutes to do this quiz. Nothing else. When I say work with a partner, I had somebody last class, they had a partner, and them and their partner did absolutely nothing together. The partner got like 100 on the quiz. The other person got like a 20 on the quiz. What sense does that make? Help each other. That makes no sense whatsoever. Get with your partner. Problems. Listen real quick before you move. Problems 1 through 9 and 12, because I'm going to explain this once. If you ask me, I won't answer it. For 1 through 4, just give One line. They say name all the parallel lines. I just want one. For 5 through 8, they say give all the angles. I just want one pair of angles. One pair. If you write this answer down on your paper as your pair of angles, what do you know about it? It's wrong. You've got to have the angle symbol. You got 10 minutes from right now. That means you got till 9:35. No more. Start. When you're finished, you will read the board and the board. Next, write down this title. This is today's notes. Perpendicular lines. Perpendicular lines. We're going to move extremely quickly here. Things that we're going to cover in this section. Find distance from a point to a line. We talked about this earlier this year. If you're finding the distance from a point to a line, how do you want that distance? If you're going from a point to a line, I think we did it a couple sections ago. Probably had me out in the desert somewhere. We want the distance to be the shortest path, correct? And what's going to make it the shortest path? How are you going to know it's the shortest path? All things are straight. All lines are straight, I should say, not all things. All lines are straight. Give me a better answer.
Parallel, perpendicular.
It's got to be perpendicular. Thank you, Mackenzie, for letting me die out in the desert, walking me parallel to the road. What a nice person.
Hey!
Prove and use theorems about perpendicular lines. Solve real life problems with perpendicular lines. I'm just kidding with you, Mackenzie. Mackenzie, what should you be doing right now?
I wrote it down.
All right. Again, if your binder,
You don't need to. Make sure y'all write.
It just said like
thank you, Thor. I'm just gonna point at you, and you can
So you really don't
know
need
what
that
I'm
on the
thinking,
first
right?
slide? You really don't need that stuff on the video.
I wouldn't mind if you had this down. It's not a big deal because usually we're struggling for time, so this is more important than the title. I know Zach doesn't want a detention there. He doesn't want to come up here and pick him up, so he'll never ever do that again.
I made it.
I don't care. Did I ask that question? Was there an if and then statement on my rules that says, if you shoot a piece of paper at my trash can and you make it, then you don't get a detention? That wasn't on there, was it? It says, if you throw something in my class, then what happens? You get a detention, regardless.
Is there any symbols for that or no?
For what?
For that theorem, you know? Is that to get you
Yeah, say that.
like what's
That's the Ebersol theorem.
well, it's a symbols because that's too much to write.
Oh, is it too much to write? All right. Which question, Caleb?
Someone on that detention bonus will I be?
Just make sure you keep yours, and the other one can be just when you toss them one away, throw the other one away.
I get you.
Nah, because if you give me the same number somebody else gives me, then I'm going to know it was you that screwed up my plan. Distance from a point. As soon as you hear the word distance, a couple of things you should think of. Number one, when we talk about this distance, don't tell me straight. What's it going to come down here and form? It's going to be a right angle. It's going to be perpendicular. So we want that right angle. So anytime you hear distance, that's what you should think of. It's got to be a right angle. It's got to be perpendicular. What's the other thing you should think of? You know you're finding the distance. What are you probably going to have to remember? The distance formula. Now a lot of you thought that, hey, we're done with the distance formula. I don't ever have to do it again. That's wrong. We're going to be doing it all year long. Distance formula. Couple of things. How are you going to know when you're using the distance formula? We talked about this earlier this year. When you use the distance formula, what might be something in a problem to point out to you, hey, I'm using the distance formula? If it's on a what? If it says find the distance. Find distance, that's you're probably using distance formula. Give me something else. If you're on a what? You can only use the distance formula when you are on a graph. Number 3, you
can only use the distance formula when you're given, what are these things called? Coordinates, ordered pairs. All right? Please remember, I know a lot of you laughed at me first chapter when I said this. You got an X and you got a Y. But when we took that first chapter test, and I gave you some points to graph, and everybody said, oh, nobody will ever make that mistake. And there was a lot of them that did on that first test. What does this tell me to do, this 5 and negative 2? How's the 5, what's the 5 tell me? So this tells you right or left. What's the negative 2 tell you? Up or down. So what's it tell me to do? How to graph it? Right? 1, 2, 3, 4, 5, and then what? Down 2. That's where your dot is. A lot of people still doing them backwards. And I know why you're doing them backwards. You're doing them backwards because last year in algebra, you dealt with slope a lot. And slope does it backwards. It goes up or down first, then right or left. So don't get it confused. When you're looking at an ordered pair, you go right or left first, then up or down.
It's kind of like reading Mega. Well, it's Japanese, so it's read right to left. When in English, you read left to right. Yeah, I trust it. I trust the Mega in my backpack.
Why can't trust the Japanese? Mr. Herb's gonna get to read books backwards and stuff. Or weird.
I'm going to send it.
Send it to
Anytime I have trouble with Board, he's been helping me out today, so I'm going to do it today. But when I have trouble with him, I'm going to send that down to Mr. McKnight and say, he's a racist or something. He needs some counseling. You'll be down there every day you'll be down there every day in intervention with Miss New Crow setting for your counseling. Wouldn't that be fun? I believe you. On this, construction. Remember, construction is making something. Put your notes off to the side and get out the other stuff that you grabbed off the table over here. I am going to do the first step. Listen, because you're going to be confused. And I'm going to collect this maybe here in a second. Just because people get on my nerves talking while I'm talking. You're going to do these steps. I'm going to do the first step along with you. Remember, construction is just making something from something else using some tools. All right? So our construction here. First one says, put the point of your compass on point P. You have a picture like that on your paper. This is the point of my compass. George is going to find the point of his compass. And he's going to, please make sure you're not doing this with your compasses again. Just because. You got your compass, you take your point, you're going to stick it on point P. And you're going to do this. Watch closely because I'm going to show you this, then you're on your own. Got it on point P, mine won't stay very well, hopefully yours stays better. You're going to draw about a half circle. You want that half circle to intersect the line twice. So put it on point P.
How much do you want it out?
That'd be all right.
How much do you want it out?
It doesn't matter. Just so it touches the line twice.
So it don't matter like
No, as long as it touches the line twice.
my pencil.
Fine one.
I think my thing is pretty good.
How do you do it?
you have it intersecting, I want you to do 2, 3, 4, 5, 6, 7. Do them on your own. So, read the directions and do what it says. You can handle that, right? Jacob, you can handle that, right? Jacob can't handle the reading. Caleb, help him out and read it to him, all right? In case he has trouble reading it. George, I wouldn't have been a smart aleck right there, but Jacob said, I don't know if I can handle it or not. I was just returning the paper. Read the directions and try. And remember, you passing or failing this class all depends on these 7 steps that you're doing here. If you don't do it right, F for the year. So when I'm saying that and I'm being sarcastic, make sure you're trying. That's what I want. I want to see you trying. Brandon's got a good idea. He's back here and he's cheating off Sierra. That's great. Do that.
That's not smart.
Well, I didn't say it was smart. I said it was a good idea.
You said draw an arc.
Draw an arc just like mine, and then do the rest of it from there. As you're trying this, I'm going to call off your name. I'm going to call off your name. All you're going to do is tell me your number that you picked. So as you continue on, I'm going to call your name. All you got to do is tell me the number. Say it loud because sometimes I can't hear real well. Thor.
22.
Kevin. 18. Mackenzie. 2. If I spell your name wrong on this, I apologize in advance. Kelsey.
26.
Cameron.
13.
Madison.
8.
help me out. So on this, watch closely. I'm going to finish this out real quick. Label the intersections A and B. So where this arc crossed that line, I'm going to label one of them A, one of them B. If you didn't do that, you should be doing it right now. Put the compass point. So we take our compass again, put the point on A, and draw an arc below the line. I don't have very much room down here below mine. Yours, you have a little more room, so you put it on A, you're going to draw an arc, something like that. Don't move your compass. Go over to B, you do the same thing. We want those two arcs to do what? Intersect, and mine did right there. And then the next step says label that. What'd they say label that? Q. Next step said draw line PQ. So I'm going to take my ruler, put it right here on this, and I'm going to connect those two. So we have that line QP or PQ, whichever way you name it. Then it says the last thing, measure the angles. Somebody measure this angle for me. What'd you get?
90.
What?
89.
I got 90. I got 90.
90.
What's going to happen here with the construction? What this is, we're forming two things that are perpendicular to each other without actually just taking a protractor and measuring the angle and drawing it that way. Every single time, if you do this process right here, every single time, the line that you draw will be perpendicular to the original line. Every single time. It's going to form right angles. Right? That's what a construction is. If you need right angles here for some reason, this is the process you would use to make sure that it's a right angle every single time. Now, when we did this, notice that everybody's compass set at the same points, same distance every time? No, doesn't matter. If you do this process the way we did it right here, these angles every single time, all four of them are going to come out to be right angles. Looking at the next one. On the next one, I'm going to do the first step for you again, then you're on your own. Spread the compass so that it's more than half the length of segment AB. So you're going to take your compass. Actually, I'm going to do the first two for you. You're going to take your compass. Do I want my compass to be about that wide? No, it's got to be more than half. So maybe something like that. Now, is Kelsey's compass going to be as wide as my compass? No. All right? Mine's going to be wider because I'm doing bigger stuff up here. You take the compass, make it more than half. Does that look like more than half?
Yes.
And you're going to draw an arc. When you draw the first arc, you put it on A, you draw an arc, comes around something like that. Don't move your compass, and you do the same thing. You go over to B, and you draw another arc. And you want those two arcs that you draw to intersect each other. So I got two intersection points. Make sort of like a little H shape there or something. Once you do that, you're going to do the rest of these steps on your own. Take a couple minutes to do them. Do the rest of them on your own. Try. Don't just sit there and do nothing. Try. Brandon, I left off with you, right?
Yes.
Correct. Jacob, give me your number. You said 24?
Yes.
No, give me your number. 4?
Yep.
Zach, give me your number. George, you working? Yep. Don't lie to me. All right. Tyler, give me your number. 25? Taylor, give me your number.
16.
Caleb, give me your number. 14. Rebecca, give me your number. Say it one more. Keep trying, don't just give up.
What are we doing? We're done.
Meditate on it.
And I can't. Stand in the right position.
What are those two to each other? So, on this, put the compass point on B, draw an arc, crosses AB, so on and so on. Twice, I guess we'd already did that one, didn't we? Label the intersections P and R. So what am I going to label this point right here? P. How about this point? Then you're going to do what with those? Make a line. Take your ruler, draw in a line. Somebody name that line for me. Line PR. Label the intersections of the segment and the line. Point M. Anybody have a guess as to why, when I was making this up, I named it point M?
Midpoint.
It's a midpoint. So what's true about segment AM and segment BM or MB? They're congruent to each other. Picture went nuts here. Previous. So I know those two are congruent to each other. Next thing they ask you is to measure this angle. Anybody measure that angle yet?
90 degrees.
90 degrees. Very good. Guess what these other three angles are? 90 degrees. On the last one, math people, very creative. Cameron knows this very well. His mom probably is upset with his dad all the time because he's so creative, isn't he? Your dad's a little more creative than most math people. That's why he does middle school stuff. But people like me and Mr. Alexander, there's no creativity whatsoever. Math people, very, very creative. Line PR that we just drew there, and everybody drew that same line, even though, did I tell you to set up your compass on the same settings every single time?
No.
No, all of you did something a little different probably. Line PR is called, what did line PR do to that segment? It bisected it and,
Midpoint.
it bisected, that's a midpoint, and what else? It's perpendicular to it. This is how creative math people are. Guess what that line is called?
Perpendicular bisector.
Perpendicular bisector. If you want creativity, you need to go over to the science classrooms. Those people are more creative. They come up with names like Xeon and stuff like that, to just random names to put on stuff. Math people call stuff just
Uranium.
perpendicular bisector. Why is it a perpendicular bisector? Because it's perpendicular to it and it bisects it. Very, very creative.
Perpendicular bisector.
On your notes, next piece of notes that you're going to put on there. Set that stuff off to the side. And locked up. Perpendicular bisector. Very important that you know what a perpendicular bisector is. I like to put stuff like perpendicular bisector on my test because that when I can use a phrase like this that tells you a whole bunch of information and I don't have to type anything but 2 words, that makes me happy because I'm terrible at typing. So when I tell you something's a perpendicular bisector, what's it tell you about these 2 segments? They're congruent. What's it tell you about these 4 angles? They're all 90. They're all right angles. That tells you a lot of information. Perpendicular bisector. Tells you a lot of information in just a couple of words. Yep. Every day of the year. Make sure you bring me a present. Every day. What's today, the 26th? Hey, today's my birthday. What's tomorrow? 27th. Hey, it's my birthday. Or we could go with the Alice in Wonderland thing. What's
You don't get the 29th as
has anybody ever seen Alice in Wonderland?
Yeah.
You know,
Everybody seen Alice in Wonderland?
Yeah, Mad Hatter.
Then what's the rabbit talking about when he's going to the party? What kind of party is it? It's an unbirthday party. Today's my unbirthday.
Yeah, it was for the Mad Hatter.
So every day, Mackenzie, when we come in here, I'll tell you, when you walk through the door, I'll tell you, either it's my unbirthday or it's my birthday. And then you can figure out when my birthday is
Hey, let me
if
tell
you're
you,
paying attention.
everyone has 364 or 65 depending which year it is, unbirthdays, and then one birthday.
So you'll have to figure out which one is my birthday because I tell you that. Today is my unbirthday. I'll tell you since I don't see you tomorrow, tomorrow's my unbirthday also.
Hey, want your pencil? There's your gift for the day.
Happy. So we need to sing the Alice in Wonderland song. Happy happy unbirthday, happy happy unbirthday.
And Mr. Herbert's song. My birthday was really wrong.
Perpendicular bisector. Somebody read this to me real quick before I change the slide. Normally I won't write out that much. This is what I would write. Too much chatter today. Line AB, perpendicular bisector. I'll write it just like that. Of segment GK. This last part here always has to be a what?
Segment.
Has to be a segment. Why can't it be a line?
Lines never end, so you can't bisect.
You can't bisect them. I had an argument yesterday with a student. And I drew a line up here. And I said, come up and find me the middle of that line for the midpoint. So he came up and he did that. And guess what I did to my line? Extended on out. And I said, no, you're wrong. So then he goes, well, it's right there then. And then I extended it on out. And I said, no, you're wrong. You can't bisect a line. What's the other thing you cannot bisect?
Array.
Array. Can't bisect array. Can't bisect lines. Can't bisect rays.
Or points or planes.
Or points or planes, that's true. Write these 3 down. Again, with the numbers, do I really care about the numbers? No. This one here is wrong. This should be, and I changed it, but my slide, I think I unplugged my computer yesterday and I never saved it.
When are we getting different seats?
Never?
Maybe here in a couple minutes.
Okay, yeah, I see.
Why you gotta open your big mouth?
If a line is perpendicular to, right. The first one, you know that these two are a linear pair. And you also know that they're congruent. What's the only number in our number system that both those statements can be true? They're a linear pair. What's it tell you when they're a linear pair? They add up to 180. And what's it tell you when they're congruent? They're the same. All right? So they add up to 180 and they're the same. What's the only number that works there? 90, right angles. That's what this says. If 2 angles are a linear pair and they're congruent to each other, then they got to be right angles.
these next two theorems. These are sort of silly theorems. You never ever have to use these theorems if you don't want to, because we could always use all those theorems we've learned up to this point. If I'm looking at these two, what do I know about these two lines in 311 here? What do they tell us about those two lines?
They're parallel.
They're parallel. If they're parallel and that angle's 90, what's this angle over here? 90, because alternate interior angles have to be congruent. So we could use that. But this theorem says if you have two parallel lines and a transversal, and one of the parallel lines is perpendicular to the transversal, then the other one's got to form right angles with the transversal. But we could use all those other theorems that we already learned. And this one is just the converse of that. It's the converse. It switches it around. So it says, if I know that these two angles are both right angles, then what do I know about these two lines? They have to be what to each other? The two lines have to be what? Parallel. So it just says the reverse, the converse of it. These little pencil leads get laying all over my everything. I didn't turn it. It switched on its own. Take it home, show it to your dad. That way he knows that we're doing something in class. We're not just sitting here goofing off. Because when he sees your grade, that's probably where his impression is going. Where would you get that grade? You looked at your grade here later? That's good. That's what I mean. Is that a normal grade for you in math? So maybe it won't take you away. Beginning of the year, then you go downhill a little bit. Gets a little harder, and you sort of slack off a little bit, maybe get tired. George, that was a Mr. Ebersole comment you just made. What? That you said to Jonathan. That was one of my comments. What did I say? What did you say? Maybe it wasn't you. Maybe it was a Noah. Probably Noah.
What did you think I said?
I'm not even gonna make it because it was a sarcastic comment. Smart aleck comment. How close is Jonathan?
Why do you ask?
What?
Do we have to keep you want us to go these other
Don't worry. Write this down real quick. We only got 5 minutes, but we're going to do this 2-column proof together so you have an example of it there in your notes. Wait a few minutes. We'll get it. We got time. Shouldn't take you but a second. Write that. Draw the picture. What's the first piece of given information tell us? So these are one piece at a time. So these two are parallel. So let's mark that in our picture. Those two are parallel. We put the little arrows on there. Shows that they're parallel. What's the second piece of given information tell us? J is perpendicular to H. So J, the transversal, is perpendicular to H. Tell me what that tells us. Pick an angle. These two are perpendicular. What's that tell us?
1 and 2 are 90 degrees.
Pick one of them. 1. Angle 1, 90 degrees. We'll put a box in there. Shows that that's 90 degrees. Now, before today, before we had those theorems that we just had on that other page, we'd need to go through and say, okay, angle 1 and angle 5 are what kind of angles to each other? Corresponding. They're corresponding, and then we could say that they're congruent, and then from that, do whatever. Here we don't need to do all that, because we just had a theorem that said if these two lines are parallel, and this is a right angle, what do we know about all these angles down here?
They're all right angles.
They're all right angles. So what's that tell us about these two lines? They're what to each other? Perpendicular. We should be able to write this two-column proof fairly easily. What's our first statement going to be? H is parallel to K. How do we know that? That was given. Can we say anything else about H being parallel to K? There's a whole lot we could say. We could say angle 3 and angle 5 are alternate interior angles. Angle 4 and 6 are alternate. We could say all that. Do we need any of that? Not this time. What's our next statement going to be? J is perpendicular to H. How do we know that? It's given. So now we're saying H is parallel to K and J is perpendicular to H. So what's that tell us about J and K? They got to be perpendicular. J is perpendicular to K. And the way we knew that is one of those theorems. Somebody read that theorem that we just had that said if it's parallel to one parallel, or if it's perpendicular to one parallel line, then it's got to be perpendicular to the other. What's it say? The other one. So if perpendicular to one parallel line, then what do we know? Perpendicular to the other. That's it. The more theorems and stuff we get, what should happen to your two-column proofs? Should get shorter because you got more rules you can use. That's your assignment. We got like 1 minute. Listen closely. You are going to... George, is that your jacket? Yeah. Will you move it for me? Yeah. You are going to look at the seating chart. All right? Just get an idea where you set for next class. Also, you're going to grab one of these sheets. These are your passes for the second 9 weeks. So grab one of those, look at that. Make sure you write down the assignment. Also, make sure you put the stuff back in the boxes. Put all my stuff back in the boxes for me, please.
Thor.
Take a picture of it.
Ah, good thing. Brooke, grab her binder. Whose other binder is this up here? Have you got your binder back from when I collected them a long time ago? Stay on. Do the homework.
I sit in between Kevin and Thor.
I said what? Kevin and George.
Wait. Okay.
Yes, I love it.
Sit right here. Right here.
Excuse me.
Where do I sit? Hey, you. I sit behind you. I sit behind front.
If you don't take the passes, if you don't take the worksheet for the passes, when you ask me for one, I'm going to say nope.
I love makeup.
You should grab the passes up there.
That's the front of the room.
I'm still lost in where I am.
You got to say right.
The front of the
Mr. Erbisol, did we get new seats?